Hi guys. So in this video we would be solving a latest DSA question which was recently asked in Amazon online assessment. So this problem says that we have one binary string which consists of zeros and ones, and we also have an integer value k, and the goal of this problem is to return the length of the longest consecutive sequence of ones. So this is basically the consecutive sequence of 1. This is another consecutive sequence of 1. This is another consecutive sequence of 1. So I need to find the length of the longest consecutive sequence of ones after performing at most k operation. And how does the operation look like? So in one operation, we can take any substring. Let's say this is one of the substring, and flip all the characters in that substring. So 1 will become 0 and 0 will become 1, like this. So I hope you understood the question. Now let's start solving it. So one thing that you would agree with me is, since I have to find the length of the longest consecutive sequence of ones, why should we flip a character which is already 1? Because if I, let's say, make this character to 0, I will surely not get the length of the longest consecutive ones, right? Because we are converting a already one character to a 0. So that's the reason why we should not flip a character which is already 1. Okay. Now let's check the answer for the test case number 1. So this is the string, and we can perform at max 2 operations on it. So we know that we will not perform operation on character 1, so we should always perform operation on character zeros. So this is the first sequence, that is a first substring, and this is second substring. Obviously, why would I perform a flip on the small substring, right? That is, why should I perform a flip on this substring if entire part can be flippable, right? Because if I flip entire part, the addition would be 2, because these two zeros will become 1, right? So total summation or total number of ones after the flip would be 2, right? That's the reason why we should take the entire substring of zeros, like this. So this is one substring of 0, this is second substring of 0. So there are two substring of 0 and there are two operations. So let's convert both of the substrings to 1, like this. So after performing k operation, I have converted all the zeros to 1. So the answer of this would be 7, because there are 1, 2, 3, 4, 5, 6, 7. There are 7 ones in a consecutive sequence, right? So the answer for test case 1 is 7. Let's take out for test case 2. Now the test case 2, there is one substring of 0, there is another substring of zeros, and we only have one operation, so we can only convert one of them. So let's convert the one which has more number of zeros, that is this one. So the answer would be 5, right? These are the 4 ones and this is the fifth one. So the length of the longest consecutive sequence would be 5. If we would have converted this all zeros to ones, then the answer would have been 4, which is smaller than 5, right? So now you might think that whenever there is a consecutive sequence of zeros like this, one has 4 consecutive zeros and one has 3 consecutive zeros, so we should always choose that one which has more number of zeros. This is what you might think right now, but no. I'll show you one more test case. So let's say this is the third test case. Again, we have only one operations to be performed. So this is one substring of zeros, and this is another substring of zeros, and this substring has more number of zeros. So ideally, we might think that let's convert this zeros to 1. But if we do so, the answer would be 4. Okay. But instead, if we convert this 0 to 1, the answer would be 7. This is 5 plus 1 plus 1. So answer would be 7. So hence, we cannot use that greedy approach where we would take the substring of 0 where more number of 0 is present. Okay, right. Now, another thing that I want to highlight is whenever you see a problem where we need to find, where keywords like at most and longest consecutive sequence or something like is present, believe me, that problem has higher chances that it can be solved using sliding window approach. Okay, so let's try to use sliding window approach in this problem. But before that, let me tell you one more thing. So this is what I have already told, right? If if this is the substring that I will be converting to ones, right? All the zeros would be converted to ones. Obviously, I would not take a smaller substring like this, right? I would directly take the bigger substring of zeros like this. So let's merge all these ones and all these zeros like this. So let me show you that. So what I meant is, so I'll create one array which will represent the clubbed portion of this string. That is, all the ones would be represented by one integer. So this 5 represents count of this subarray or sequence of ones. Okay. Then 1. This 1 represents sequence of zeros. Okay. So there is only the size of the sequence is 1. This is what this 1 is showing. Okay. Then one more 1 will come because this one represents the sequence of this particular one. Then 3 will come because 3 is representing the sequence of these zeros. Now you tell me that what is this one representing? This one is representing the sequence of zeros, and this one is representing sequence of ones. Now, how are we differentiating between this? Obviously, we can't differentiate, right? So I need to modify this thing little bit. That is, I'll add a minus sign over here and over here. Now, whenever I see a negative number, then it means that it represents the sequence of zeros. Whenever I see a negative number, it represents a sequence of zeros. And whenever I see a positive number, it represents a sequence of ones. Okay, I hope you understood this part. Now let's continue with our sliding window approach. Okay, so obviously let's follow the template that sliding window says. So I pointer will be over here, j pointer will be over here. And what is the goal? The goal is to maximize the number of ones. So let's maintain one variable ones. So this is showing how many ones are there in this particular window from I to j. So initially it will be 0. And how many flips have we performed till now? So initially it will also be 0. Okay. So now first j pointer is standing at index 0, and this is a positive value. It means that it is representing sequence of ones. So is there any need for doing a flip? No, right? There is no need. So we'll directly take this particular sequence into ones. So let me edit that. So I have added. So till now we have encountered 5 ones, and obviously j will also move to this particular index. Now, now this element is a negative element. It means that we are having a sequence of zeros. And if I want to take this sequence of zeros, I need to perform a flip operation. So let's do that. So I have performed one flip operation. So I will take all the zeros. So there are only one zero in that sequence. So I've added that into count of ones because this zeros would be converted to one after performing a flip operation. Okay. Now J pointer will move ahead. Now it is a positive value like this. So it already represents a sequence of one. There is no need for flip, but we can directly add that into the variable ones. So let's do that. So it will become 7. Okay. Now J pointer would move ahead. Now notice this is a negative value. It means that it represents a sequence of zeros, right? So let's add that. So 7 will become 10. Okay. So I'm writing this 10 over here for temporary, and flips will also be incremented because this is a sequence of zeros, right? Now just see the total number of flips that we can perform is 1, but we have performed 2 flips. It means that I have to shrink the window from left hand side. This is what sliding window approach says. Okay, whenever a condition fails, we have to shrink the window. Now, obviously, we will shrink the window up till one of the zero sequence is removed. That is, currently we are over here, right? I is over here. So we'll keep on incrementing I till one of the zero sequence, that is this is removed. So we will remove this particular chunk. Okay. So I will remove this from the sum 10. Okay. So it will become 5. It will become 5. Okay. And I will go over here. Now I will also remove this particular one. So this 5 will become 4. And here we have performed a flip operation in order to take the ones, right? So we will reverse that part. That is, I would increment the flip count. I mean, decrement the flip count, right? Then I pointer would move over here. And here you see that flip count is less than equals to k count. It means that I to j part is valid and it is showing total number of ones present in this I to j window is 4, right? And it is through, right? So total number of ones in this particular highlighted part is 4 after performing one flip. And what is the maximum number of ones that we have observed? It is nothing but 7, right? So we would also maintain one variable where we would store the maximum value of ones reached at certain point of time. So I hope you understood the approach. If you have any doubt regarding this explanation, please comment down. Let's move to the code part. Okay. So I've taken the same string that we were working on, and the k value is 1. It means that I can perform only one operation. I've defined one function, length of longest consecutive ones. So let's see that. Okay. So first of all, from this string, I am getting the clubbed portion of array. That is this particular array. Okay. So this is how I'm getting. So initially count is equals to 0, and initially this character would be the first character, that is this character. So as long as I am encountering the same character, I will increment the count. And once I find another character, that is this character, at that time, I will push the count into the nums array. Okay. And I will re-initialize the count to 1 and I will change the character. Okay. And I will push the count directly if it is 1, but I will push the negative version of the count if it is 0, as discussed, because we should be differentiating whether that number is pointing to a sequence of zeros or a number is pointing to a sequence of ones. That's the reason why we are putting negative over here. So this is how we get the array, and then this is the normal sliding window template that we use. So I'm adding the summation value. I'm taking the absolute part because that represents the total number of zeros or total number of ones. And if the number was negative, it means that I should have performed a flipped operation to get the sequence of zeros into my sum value. So that's the reason why I am decrementing the flip count. And while the flip count is less than 0, I'll shrink the window from the left side. That is, I'll perform the opposite step of this particular part over here, and I will shrink the window. And at every point, I'm tracking the maximum sum. Okay. And finally, I will return the maximum sum. Also, don't forget to increase the J pointer, which I think many people forget that. So let's check out the answer for this. The answer for this should be 7. So let's check out that. Yes, it is 7. So I hope you understood the code part as well. If you have any doubt, please comment down. I'll try to answer that. Thank you.